Hello everyone. In this lecture we are going to study about the special function, and the special function in this lecture we study is Legendre function and Legendre polynomial. Introduction to special function and the differential equation from which we find out the special function. First is Legendre differential equation, 1 minus x square y double dash derivative of second derivative of y minus 2x y dash, that is 2 into x into first derivative of y, plus n plus 1 y is equal to 0, where n is a real constant, is called Legendre differential equation, and the solution of this Legendre differential equation is y is equal to a p n x plus b q n x. The solution we obtain for this, where p and x is a Legendre function, and the solution this solution we obtain by using the assumed series solution for this differential equation, which we have studied in previous lecture. First we have to assume the solution of this in the form of y is equal to, in the form of summation, n is equal to, or r is equal to 0 to infinity ar and x to the power k minus r in this form. Then we get this solution where p and x is a Legendre function, and his second differential equation is x square double derivative of y plus x y dash plus x square minus n square y is equal to 0, where n is the order of this differential equation and n is real constant. This equation is called Bessel's differential equation, and the general solution for this Bessel's differential equation is y is equal to a jnx plus b jn minus x, where j and x is the Bessel's function. Again, for solving this equation by using the series solution, that means y in terms of summation, r is equal to 0 to infinity, then we obtain this general solution for Bessel's. Now, Legendre equation and Legendre polynomial. The differential equation this we solve by using y is equal to, assuming y is equal to summation r is equal to 0 to infinity ar x to the power k minus x. When we substitute this equation in our equation, then it's not satisfy, and solving this we get a general solution, this, where the value of p and x is 135 multiple in an odd term upon factorial n into the complete term. That's why we called it as a polynomial. This is for q, the value of q. Now the Legendre polynomial of n degree. So this is the value of p and x, Legendre of n degree. Now if we substitute in equation a, if we substitute the value of n is equal to 0, we obtain p0 is equal to 1, and the value of p0 is equal to 1 we also find out by using the Rodriguez formula, which we are going to study after this lecture. When we substitute the value of n is equal to, when the value of n is equal to 1, we get x. When the value of n is equal to 2, we get 1 by 2, 3x square minus 1. This is the value of p2x. Similarly, for p3x is 1 by 2, 5x cube minus 3x. This value we obtain when n is equal to 3. For n is equal to 4, we get 1 by 8, 35x to the power 4 minus 30 x square plus 3. Similarly, for n is equal to 5, and so on. Now, how to express any polynomial in terms of Legendre polynomial. Now first we consider one example. The example is express function fx, that is 4x cube plus 6x square plus 7x plus 2 in terms of Legendre polynomial. To express this function in terms of Legendre polynomial, let me assume in the form of Legendre polynomial this function, that is, let 4x cube plus 6x square plus 7x plus 2 is equal to a into third order of Legendre polynomial p3x, because over here we have x cube. Similarly, for x square we replace by p2x plus b p2x. For 7x we replace c into p1x, and for the power of 0 we will substitute p0x. Now the values of p3, p2, p3, p2, p1 and p0 we substitute, which we have previously calculated. So substituting the value of p3, that is 5x cube by 2 minus 3x by 2. Substituting the value of p2x, that is 3x square by 2 minus 1 by 2. Substituting the value of p1, that is only the x, and the value of p0 is 1. Now we simplify it and we find that this is equal to 5ax cube plus 3bx square plus minus 3a by 2 plus c into x minus b by 2 plus d. Now when we compare this term with the same order of x from left side, the function which is given in the problem, we find that 4 is equal to, when we compare this value, 4 is equal to 5a by 2. Similarly, 6 is equal to 3b by 2. 7 is equal to minus 3a by 2 plus c, and 2 is equal to this value. Now we simplify. The value of a is 8 by 5, value of b is 4, value of c is 47 by 5, and value of d is 4. Now we substitute the values which we have calculated, that is the value of a, b, c and d in our assumed solution, that is in equation 1. Now we substitute the values over here, a, b, c and d. We find that the given problem in the form of Legendre polynomial is 8 by 5 p3x plus 4 p2x plus 47 by 5 p1x plus 4 p0x. So this is the required solution for the given problem. Now this is the problem for the practice. First question is express x to the power 4 plus 2x cube plus 2x square minus x minus 3 in terms of Legendre polynomial. And the second question is express x cube minus 3x square plus x minus 1 in terms of Legendre polynomial. The question is exactly same which we have calculated previously. For any doubt and any query related to these questions, contact your class concerned faculty. Now, but these questions should be solved by you. If there is any mistake, you have to submit that wrong calculation to your concerned faculty. Now the Rodriguez formula. Now Legendre polynomial is expressed by Rodriguez formula, and this p and x representing the Rodriguez formula, that is 1 by 2 to the power n factorial n time derivative of x square minus 1 to the power n. If we substitute the value of n is equal to 0, we find that p0x is equal to 1, which we have already previously discussed. The actual value of p01 in few derivation is already given, that at the time of driving the any formula, the p0x is given is equal to 1. This is calculated by using the Rodriguez formula. Now when we substitute the value of n is equal to 1, we get p1x is equal to x. Similarly, when substituting the value of n is equal to 2, we get 1 by 2 3x square minus 1 for p3, p4, p5 and p6, so on. But when we graphically draw this p1, we find that p1 is from 0 to 4, p0 is constant at 1, p1 is from 0 to 1, this is the place of 1, p2 is from minus 5 to 1, p3 is this graph. This is the graphical representation of p1, p2, p3 and p4 and so on. Now the orthogonality property of Legendre polynomial. The orthogonal property of Legendre polynomial is if the integration from -1 to 1 Pnx and Pmx with respect to dx is equal to 0. If m is not equal to n, if m is equal to n, we have 2 upon 2 to the power n plus 1. This is the orthogonal property, can be represented either in this form or in this form. And sometimes a multiple objective questions come like let P and X is a Legendre polynomial of degree n greater than 1, then what will be the value of the integration -1 to +1 1 plus x P and X is equal to. Now to derivation of this orthogonal property, let Legendre polynomial P and X satisfy the following orthogonal property, that is integration -1 to 1 Pmx dx is equal to, value is 0 when m is not equal to n, value is 2 upon 2n plus 1 when m is equal to n. To prove this, let we assume let we take differential equation using differential equation, the Legendre polynomial polynomials Pmx and Pnx. The equation is 1 minus x square y double dash x minus 2 x y dash is a function of x plus n plus 1 y is a function of x is equal to 0. Then if the Pmx and Pnx is the polynomial for the equation 1, then it must satisfy it. So we substitute it over here, we get 1 minus x square Pm double dash minus 2x Pm dash plus m plus 1 Pm is equal to 0, equation 2. Similarly for the second value, 1 minus x square Pn double dash minus 2x Pn dash plus n plus 1 and Pn is equal to 0. This is equation 3. Now we multiply equation 2 with Pn and subtract from the third equation, multiply with Pm. Then we get 1 minus x square Pm double dash into Pn minus Pn double derivative into Pm minus 2x Pm dash Pn minus Pn dash plus m m plus 1 minus n and n plus 1 into pm pn is equal to 0. Now by using the first two terms, we find that if we combine first two terms, we get a differential form of, that is, this first two term is equal to d by dx of 1 minus x square into pm dash pn minus pm pn dash. Now if we differentiate it by using the product rule first and second, we find the previous first two terms plus the remaining term is m minus n into m plus n plus 1, then pm and pn is equal to 0. Now this is the equation B. Now integrating equation B over minus 1 to 1 with respect to x, we get from the left side of this, because over here we have a differentiation with respect to x, so we get 1 minus x square into pm dash pn minus pm pn dash for the limit minus 1 to plus 1 plus m minus n is treated as a constant. Similarly, m plus n plus 1 is a constant, and integration from minus 1 to plus 1 for pmx and pnx dx is equal to 0. For the first term, if we substitute the value, the upper limit, when we substitute the upper limit over here, either plus 1 or minus 1, we find that it is equal to 0. The first term is neglected. This will be equal to 0. So we only have the term, that is m minus n into m plus n plus 1 into integration minus 1 to plus 1 pmx into pnx dx is equal to 0. Now this is the constant. Now the actual, we receive the term that will be equal to, when n is not equal to 4, m is not equal to n, we have integration minus 1 to plus 1 pmx pnx dx is equal to 0. So this is the first proof which we obtain for it. Now for the value m is equal to n, we use generating function. Generating function of Legendre polynomial is 1 minus 2xt plus t square to the power minus 1 by 2 is equal to summation n is equal to 0 to infinity pnx and t to the power n. Why we call it generating function? Because expanding this term and taking the coefficient of t to the power n, we find pnx. Now squaring both sides, of the equation, this is equation C of the equation C, and integrating with respect to x, over the domain minus 1 to 1, we get, when we square the term over here, we get minus 1, so it is equal to d by dx over 1 minus 2xt plus t square, and the integration limit minus 1 to plus 1, and for right side portion integration minus 1 to plus 1, the whole square of summation n is equal to 0 to infinity p and x t to the power n whole square dx. Now for calculating the left side, for integration minus 1 to 1 dx over 1 minus 2xt plus t square is equal to log 1 minus 2xt plus t square upon minus 2t for the limit minus 1 to plus 1. This will be equal to minus 1 upon 2t log 1 minus 2t plus t square minus log 1 plus 2t plus t square, and this is equal to 1 by 2t log 1 plus t whole square minus log 1 minus t whole square, that is equal to 1 by t log 1 plus t minus log 1 minus t. Now expanding it, the term of log, we get 1 by t, first term is t minus t square by 2 plus t cube by 3 and so on, and minus the second term for the log expansion is minus t square by 2 minus t cube by 3 and so on. Now the finally term we received is 2 into 1 plus t square by 3 plus t to the power 4 by 5 and so on, and the nth term is t to the power 2n over 2n plus 1 and so on. We just focus on the t to the power, this term t to the power 2n plus 1. Now again, by using orthogonality property, we obtain that minus 1 to 1 summation n is equal to 0 to infinity p n x t to the power n whole square is equal to summation of n is equal to 0 to infinity integration minus 1 to 1 p n square x into t to the power 2n dx, that is equal to summation n is equal to 0 to infinity t to the power 2n integration minus 1 to 1 p n square x dx. Now comparing the coefficient of this t to the power n on left sides, because this is the right side of previous equation and this is the left side which we solve. So now comparing the left side t to the power 2n plus 1 coefficient and the right side t to the power 2n plus 1 coefficient, we find that integration minus 1 to 1 p n square x dx is equal to 2 upon 2n plus 1. This is the derivation for orthogonality of Legendre polynomial. Now, the first example which is required to be solved proves that minus 1 to 1 p2x and p5x dx is equal to 0 because m is not equal to n. By using the orthogonality, it is equal to 0. And second example, minus 1 to 1 p3x whole square dx. Over here we find that m is equal to n, which is equal to 3. Now we substitute the value of n is equal to 3. We find that this is equal to 2 upon 2 into 3 plus 1. So this is the solution. Yes. Thank you. And for any doubt and any query, please feel free to contact your concerned class faculty in your doubt session. Stay home, stay safe.